And here we go. We have liftoff. Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up. Roger, roll, Atlantic.
Water towers fly! Yes! Tango down to nominal.
Flight downside FD off. Bring in FD off. Off. It's orange! 145!
Oh my god!
Decollage.
What is it?
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane would be igniting the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.
All right, folks, you all know the drill. Looks like we've got audio and video going here. Give me some 5x5s in chat. John Galloway for NSF. All the different places you may be seeing this with a very interesting story today that we're going to be talking about. I'm not kidding you. How many of you actually knew what I was talking about when I made a thumbnail that says the damaged spacecraft delayed a crewed launch? Did anybody know? Sort of ran it like it was a current headline breaking news sort of thing, but look at the picture behind it. It's like, what is that even? I didn't give really any clues. I do hope that you forgive me for, trying to create a little interest on the show today here. But this was a real thing. I mean, imagine you have spacecraft that are on the launch pad, and this mission was a complicated mission where you're launching an uncrewed bunch of equipment up into space, right? And then you have the crew that are supposed to follow right behind it, and you launch the equipment. It sounds like it's a science fiction movie or something, right? You launch the equipment, and something goes wrong. Parts falling off, damage happening. The equipment gets to space, and nobody even knows if they should launch the crew. I mean, is it safe to send crew up there? Solar panels getting destroyed, damaged, I guess you could say. Things getting stuck so they won't unfold, and you can't fix it. You don't have robots flying around. It's not that science fiction, right? But should you send the astronauts up there in an attempt to fix it? Should you just scrub the whole mission? I mean, the astronauts were supposed to launch the next day. If you don't know the mission that I'm talking about, this is actually 50 years ago that this happened. It was the Skylab mission. And today we have some fantastic stories about Skylab from folks that actually worked on it. So let me bring my special guests in here today. This is the Intrepid Museum show for the month, Astro Live, talking about what we can learn from things that went wrong with launches 50 years ago. Let's see who else we have on the show here today. There we go. I think we've got everybody. We've got Mr. Charles Lewis, retired from NASA, actually one of the engineers who worked on fixing the problems with the Skylab launch. David Hitt, an author who's actually also a NASA person, but an author who's written a lot of history about this. And we've got Summer Ash as well, who's going to be helping us with the conversation today. Tell us about this. I mean, David, you gave us like a really cool sort of background on this. We're not making this up. It's not science fiction, right? This was a real thing that happened.
This is a real thing that happened. Yeah, this is. You want the launch day story?
I want the stories. I want to hear what happened.
So May 14th, 1973, the last Saturn V is on a launch pad, on pad LC-39A at Kennedy Space Center in Florida. Short distance away on another launch pad, sitting on a stool, is a Saturn 1B launch vehicle. The plan is this Saturn V is going to launch the Skylab space station. The next day, the first crew is going to go over to the other launch pad, get on that Saturn 1B. They're going to fly up there. Again, this is the last time that a Saturn V moon rocket is leaving the Earth. And so if you're there at the Cape, if you're there at Kennedy Space Center and you're watching this launch, it is incredible. I mean, just the sheer power and magnificence of this rocket is historic, is memorable. And so if you're watching it from the launch site, it's an amazing experience. If you're watching it from the control room, however, the experience is a little bit different. Very quickly, the telemetry starts coming in, and just things are off. It's not unfolding the way that it's supposed to be. What's happening is there was a shield that goes around the workshop to protect it from heat. It's a thermal shield. It's also an orbital debris shield, kind of a dual purpose thing. During ascent, during the aerodynamic forces as the rocket is launching, airflow gets in between the workshop, between the structure of the space station and that shield, rips the shield off.
Like during the launch,
like the shield is ripped off. I mean, like you said, parts falling off of the space station
of a Saturn V.
As the rocket is launching. This is, like you say, this is real. This is a thing that happened. When that happens, the space station had two big solar array wings on either side. Now, for launch, they're mounted flush up against the rocket. When the heat shield rips off, those solar array wings. Okay, there you go. There's you're spoiling the story.
Well, you said it. I didn't show it till you said it out loud. So
you can see, you can see one of the array wings there in that picture. They're mounted, like I said, flush against the rocket during launch. The plan is once they get into orbit, they're going to deploy out perpendicular, like you see in that picture. When the shield rips off, those wings start to deploy prematurely. One of them deploys during launch, right? I mean, so everybody stuck their hand out of a car as you're driving down the street. You feel the air pressure as you're driving. Now imagine instead of going 30, 50, 60 miles per hour, you're going 17,500 miles per hour. I hope you're not too attached to your arm, because at that point your arm's not too attached to you, right? The array wing rips off. The other one, it starts to deploy, but a little strap of metal wraps around the array wing. The good news is that that stops it from deploying. It doesn't get ripped off during ascent like the other one. The bad news is it's stuck. It can't deploy. Skylab reaches orbit, but instead of a space station that is raring to go for its mission, you have a wounded space station. It has no heat shield. Very quickly, the temperatures inside the space station start getting not only uncomfortably hot, but outside of design specification hot. Your array wings that are supposed to be providing the bulk of the electrical power, one of them's not there, and the other one functionally isn't there. Again, the crew is supposed to launch the next day. What do you do?
That's this shot, right? Like everybody.
So that's it's a composite. They cheated a little bit putting the picture together. They would have been a little bit further apart.
Okay.
But yeah, that's what you saw. If you were there on the morning of May 14th, that's basically what you would have seen. Is that Saturn V in the on the one pad, and the Saturn 1B sitting on its stool
on the stool
on the other launch pad.
I gotta say real quick, the orbital launch mount. SpaceX's Starbase orbital launch mount is so revolutionary. Let me tell you about the milk stool.
Nothing new under the sun.
Like if you need all of your umbilicals in your crew access arm to line up, but you want to launch a smaller rocket than the full-size rocket, what do? Well, you just build a milk stool so that the rocket sits higher on the launch pad and all the arms and stuff like that line up. Oh, look at all the room for flames to come out. You don't need a flame trench. Like, anyways, this was a real thing. I've got composited twice in one day. It's Apollo 11th as well, and everybody knows the shot of it breaking the sound barrier past the flag. Also a composite image, if you saw that on Twitter. But this was real. This was what they were trying to do. Launch the space station. The next day, launch the crew. And then the launch of the space station doesn't go right. But we got to get into this, Charles, because Charles sent us this. Can I show the handwritten notes now, Charles?
Which one?
The handwritten notes, the SO54 procedure?
No, not yet.
Oh, not yet. Wait, what?
Not yet. Not yet.
Okay, I won't show it yet. All right.
Yeah, we'll get into that.
The spoiler, too.
While all this was going on, a bunch of us were sitting on our stools in a control room at Marshall in Huntsville.
Yeah.
And listening with headsets like this to what was going on. We didn't hear a heck of a lot. And things got kind of quiet, as David said, for a little while. And toward the end of the day, we got called up to a conference room on the second floor of this control center. And our boss, J.R. Thompson, who later became center director at Marshall, had the whole cluster laid out, the whole Skylab cluster laid out on a big conference table, and there were 3 or 4 of us in there. And he said, you know, guys, we had said we've done this failure modes and effects analysis, and we'd written mission rules and all that kind of stuff. But it looks as though we've got a problem, and we're going to be delaying the crew launch. And in the meantime, you guys need to figure out a way to erect that solar array. And we had said that it was impossible to go down the side of the orbital workshop to do an EVA because we don't have handholds, we don't have foot restraints, we don't have a lot of that stuff. But we're in a situation where some of those mission rules are likely to be scrubbed, and you guys need to go back and work on this. So it was pretty clear at that point that we had really 2 problems. One of them was the lack of electrical power. We're getting some of it from the 4 solar arrays that were attached to the Apollo telescope module, which had deployed correctly. The other problem was a thermal one. There were chemicals inside that needed to have be within a particular range, or they were going to go bad. We had to keep the interior habitable for the crew, so we kind of divided up into those 2 directions. Some of us worked on thinking about ways to get the solar array out, and another bunch went off and worked on the thermal systems. I was in that first group, and we kind of retired to our little war room. We had an office where we also had a speaker that let us listen to air to ground. But one of the nice things about this whole environment, and this comes from some of the things that led up to the development of the whole vehicle, we had access to the flight crew all along during the development. This is not unusual at all.
Right.
Astronauts need to go out and they provide sort of a cross-cutting environment that allows them to have access to any of the other disciplines. And so we'd had a pretty good relationship with those guys. They were down in the crew quarters at the Cape waiting to launch, along with the backup crew, Rusty Schweikart and Story Musgrave and a couple others. And we got a call, and they said, let me back up a little bit. We were sitting there at our table with a scale model of the whole Skylab cluster.
Yeah.
And we were at the point where we were literally working with toothpicks and string, figuring out waste. I mean, you think about this is improvisation at its best, right? Right. So we got a call from I guess it was from Rusty, and Rusty said, "What are you guys thinking about?" And we said, "Well, we're thinking maybe the first thing is that we need to get you guys to do a stand-up EVA and just fly around and see what's going on." And we also thought that maybe there was a way you could tug on the end of the solar array and break it loose, because we didn't know what was there. Weren't really sure why it hadn't deployed at that point.
Real quick, Charles, you know it's not deployed, but it's not like you have cameras all over it. You can't look at it and see what the status of it is. It's just sensors, like a switch that might have gotten flipped or something like that.
We had an image.
You did have an image? We
did have an image.
No kidding.
A ground image. It was very, very faint.
Okay.
Enough said about that. It was enough. It was good enough that we could see that array had partially deployed. So we had to extrapolate from there. So it's getting into this really neat story. If you want me to go ahead with this, it's this human interest story that we talked about before the show started.
I mean, hey, chat, should we listen to more stories? Like, I'll ask the viewers. I call them chat sometimes. So
yeah, you keep watching the chat.
You don't have to wait for the response. You can just start telling the story. They're going to say yes.
Okay, here we go. So we were casting around in our minds for ways to put a little force on the end of the solar array and break it free. And one of the guys that was sitting next to me in our office was, I think it was a MacDac East guy. And he'd been doing a little digging on the telephone circuit and looking around, talking to some of the guys out near St. Louis. And they had told him about a company in Centralia, Missouri, who made lineman's tools. Well, one of the first things that solved for us was coming up with a stick or a rod or a pole or something that was made of fiberglass or some sort of insulated material that would allow the crew to safely manipulate the end of this solar array shroud that had gotten stuck.
Like literally, they're just going to poke the end of the solar array.
Well,
or something,
we were thinking about
that's your
all kinds
idea.
of things at that point. Yeah, what do you do? You've got an image that is really fuzzy, and you go through all these things in your mind, and this is just really fundamental brainstorming.
Yeah, it's a solar
One
array.
of the nice things about brainstorming
Yeah.
is that you don't throw out anything at first glance. You put it all on the table. You categorize it and catalog it, and then you talk about it, and then gradually decide which of the brainstorming ideas are going to work. Well, anyway, it turns out this company that built they're called hot sticks, and they have end effectors that go on there with quick disconnect fasteners. You can put cutters on there, you can put hooks, you can put all kinds of things. And we said, that sure sounds like what we need, because we need to find something that exists and we're not going to be able to build it. We didn't think we could build it.
You can get by Wednesday.
3 days. We didn't know it was going to be 10 days.
Is that the repair tool? I have an image of a repair tool that has. Look at this.
So there you go. That's what we ended up with, and the way we got there is that I gave a quick call to this phone number that the MacDac guy had dropped on my desk, and the first person that answered said, "Hi, this is so and so at AB Chance. What can I do for you?" And I gave him a little story, told him what was going on, and he said, and I said, "What have you got that it goes on the end of these poles that might help us out?" And he said, "The best thing for me is to send you a catalog, because our catalog has great pictures of all of these tools that we can put on the end of the poles."
Good salesman.
And I said, "Well, wait a minute, that's not going to work." Because we're supposed to have launched these guys the next morning. It might be another day or two, but I mean, it's going to happen this week.
And he meant a physical catalog. Like, let me mail you a catalog in the mail.
I've got one here somewhere in a box. Big fat catalog.
Not email you a catalog, or let me send you a link to
No,
click
send
on the.
you.
Yeah.
Snail mail.
Snail mail. Physical catalog.
Yeah. And so he said, "Let me talk to you. Let you talk to the next guy up." And talk to the next guy up. And he said, "Well, okay. I could tell you what's there, but there's an airline strike on at the time, and there's no way we could get it to you." And I said, "Don't worry about that. If you got what we want, we'll get an airplane somehow." And because management had been going back and forth behind us saying, "What do you guys need? Money, manpower, airplanes?"
An airplane.
Whatever. Airplane. So he said, "Okay, I'm going to let you talk to the sales manager, product manager." His name was Cliff Bosch. I got to talk to Cliff, and he said, "Yeah, I understand the problem, and this is really cool. And let me go into the stacks in the storeroom, and I'll wander through there, and I'll pick out tools that might work, and I'll call you back." And he did.
I do that at Home Depot sometimes. I walk through Home Depot looking for tools that may work.
Exactly. Yeah, he called back and he said, "It's the most fun I've had in a long time. I'm just picking stuff up. I'm not writing anything down. I'm just picking it out of boxes and throwing it in another box." Well, in the meantime, the guys from MacDac had been continuing their work, and they found out that one of the MacDac executives was going to fly to Huntsville in his Aero Commander. It's a light plane, private airplane, and they were going to be bringing in some of the tools that they had developed overnight. This is kind of the next day sort of thing.
The tools they developed overnight.
They were building a cutter. Yeah, they were building all kinds of. The whole country was doing this. All of the aerospace companies overnight turned on their skunk works, and they were all building stuff on spec.
No kidding.
And so MacDac was going to send and I can't remember whether it was a cutter or whatever, but it was something that they were going to bring. So we worked out a plan where the MacDac guy would land in a little airport near A.B. Chance, near the Centralia, Missouri store company.
Yeah.
And as it turns out, Cliff Bosch said, is there another seat in the airplane? Can I come along? I'm going to give you these tools, but you really need to have some help understanding how to use them. So that's what happened. Cliff got in the airplane. I went out to the Redstone airfield later that day and picked him up. And there was Cliff with his box of goodies, and we brought him back and put him on the floor and sat around cross-legged. I think we had the backup crew there. Rusty says he doesn't remember it, but I'm pretty sure he was there.
Yeah.
Maybe Story Musgrave too. And we were just putting all these things back on their poles and everything, and trying to figure out how this might work. So,
real quick, can y'all picture this, right? Folks that are watching, do you understand what this story is? There's a space station that we launched on a Saturn V, and it's in space right now, but it's broken, right? There's a just errant piece of metal. One solar array is completely ripped off. There's another errant piece of metal that's got another one all jammed together. And all the NASA folks, and not just the NASA folks, beyond NASA, are trying to figure out what they can do based on telemetry and a grainy ground image, right?
And we're playing with Tinker Toys.
And you're playing with Tinker Toys, like putting together strings and sticks like that. Like, I don't know, what if we pull it like this? And then there's a guy who makes tools, or sells tools, I guess, right? For linemen's tools, is like telephone lines, power lines, that sort of stuff, right? Who's walking through a warehouse just randomly picking out tools. And none of these tools are meant to actually work on a space station in space. They're meant to work on power lines, telephone lines, whatever, right? And he's grabbing things out of the box, and then he doesn't have a ride. There's no next day air, I guess there's a airline strike on. And so he just hops a ride with some other person that's flying their private plane down there and brings a box of random stuff and is like, I don't know, will this fix the space station? Like, that's the story here. So far.
Yeah,
there's more.
He got up that morning and just went to work like it was a normal day,
thinking he was going to ship some catalogs.
It gets a little more serious after this, because we had to get it qualified for flight. We had to make sure that it was strong enough to do the cutter that you showed is the one that actually cut the strap. It was used normally. It's used by linemen. You can see the jaws right down here on the lower right.
Yep.
They're pretty moosey, and they're able to cut through huge copper wires on the end of a long fiberglass pole. But our engineers, who had also been thinking about the same thing, by the way, they had gone off to the hardware store looking for something like this.
It's like they're trimming their trees.
We wound up using A.B. Chance's cutters with a modified force multiplication system.
That's
on the end of the pole.
Tell me.
And oh, by the way, during that 10-day period, we also decided to use those the quick disconnect fasteners that we applied to the end of the pole to also hold a number of the sections of those poles together when the thermal on the second manned mission, the NASA sail, as we called it, some people called it a spinnaker, was deployed to improve the insulating properties. Anyway, Cliff was back. I didn't tell you the story. The rest of it.
Well, keep telling us.
We're sitting there on the
we're
sitting. That's okay. We're sitting on the floor, and Bob J.R. Thompson came walking in. You always knew it was Bob because he had size 12 shoes, and you could hear him even if you didn't see him. He comes clomping in. And he says, "Where's this guy from Missouri?" And Cliff raised his hand, and Bob told him that his airplane was going to be leaving for the Cape before too long, and because he needed to go down to help the guys at the Cape stow these parts under the command module seat, because there wasn't much else. There wasn't any other room. I mean, how else are you going to get them up there? So he had to call his wife and tell her where he was, and ask her to pack a bag, and we figured out where to send it to the Cape. And anyway, so we never saw Cliff after that day. But we sure did follow his progress. That's the human interest story that's so great. You talk about improvisation. There you go.
No kidding. I don't know if anybody else agrees with this, but I have trouble picturing that happening today, right? Like anything like that today. Are there stories like that from today, or was this very much a steely-eyed missile sort of story from the golden age of launching things into space?
I don't know that I know a story. I don't know that I've heard an environment quite like those 10 days. And and Chuck alluded to the 10 days. Like we talked about, they were supposed to launch the next day.
Yeah.
Okay, we're not launching the next day. The way the orbital mechanics worked out, there were launch opportunities every 5 days. And so, like Chuck said, originally, can we do this in 5 days? The answer was no. No, like that's too much. So it becomes, can we do it in 10 days? And that's, I don't know that there's a government agency today that could plan the meeting in 10 days.
10 days.
Like, because the incredible thing was, Chuck's giving you the engineers sitting on the floor with a box of tools.
Yeah.
But it was an around the clock thing. Marshall had a brand new center director, hadn't even moved to Huntsville yet. Rocco Petrone had been at Kennedy. He's now the Marshall center director. He's staying in an apartment. His family's still in Florida. So Rocco's just showing up, like maybe it's 1 o'clock in the morning. And Rocco shows up to, everybody's still working, like come in and check, make sure progress is still being made.
We sure were.
But the incredible thing is that none of the rigor, none of the process was lost in the middle of this. Because you've got to identify the problem, you've got to find the solutions, you've got to implement the solutions, but this is still NASA and this is still spaceflight. So you still have to qualify your solutions before flight.
Yep.
They went through the systems engineering process, but they had a high bay set up at Marshall with a row of tables, and you could go through the full systems engineering process in this high bay, just going from one table to another. Okay, let's
like
work
registering
through
for
this.
like registering for classes.
Go to the CDR table.
It's like registering for classes at college.
Just go to the next little table.
Yeah, station 1, station 2, station 3.
Get your card stamped or whatever, right? Like,
and we still had to get permission from the management council, because this was a pretty sporty EVA that we were getting ready to talk about.
And that's the thing, an EVA. This isn't a robot doing it. This isn't, we're going to jiggle the solar panel a few times remotely and see if it fixes it. This is a human being that's going to be up there, mind you, crawling along the side of the spacecraft or on the spacecraft that's not intended for a human to be there, because there's no handholds and stuff. Let me get that picture again real quick. You see on the ISS, and there's these clip-off points and safety points, and it's designed for them to be able to move around in certain ways as they work on stuff. And Skylab didn't have those handholds. They didn't have those safety areas, right? Am I missing that?
Not there.
Not where they
Skylab
needed to be.
It was designed for EVAs. There was telescopes at the in the middle of the windmill. There were the telescopes. It was designed to support EVAs from the airlock to the telescopes. The telescopes, this was 50 years ago. Film was still a thing.
That's the top part.
You had to go out and change the film. So yes, Skylab had, a wonderful, robust system of handholds, translation aids to get you from the airlock to the telescope.
Right.
Anywhere else on the vehicle was another story. There was actually a meeting at Marshall a few weeks before launch. What's our contingency plan if something goes wrong on the outside of the workshop, right? We've got all these, all of the ladders and handholds and paths from the airlock to the telescope. Right, but what happens if something happens in that section of Skylab? And they held the meeting. They reviewed all the contingency plans. They reviewed all the options. What is our contingency plan? And the answer was, there's none. There's nothing that you can do. If something goes wrong on the outside of the workshop, it's impossible to fix it. It's impossible to do anything about it.
Yeah. Did I label it correctly there? The telescope's up there, the workshop's down here. They could get to the telescope part just fine, but getting down to the workshop, it was like, well, what can we do? Nothing we can do if something goes wrong down there. And that's exactly what happened, right?
Yeah. So the meetings that Chuck is talking about post-launch, that is literally the failure is not an option moment. That the meeting where you said it's impossible is no longer an acceptable outcome.
Not an
Make it possible.
Desperation spawned out of desperation and controlled panic.
Yeah. So now I have a question. So you've worked with these guys from AB chance, and you've developed this tool and everything, and you're going through to get it all qualified. But how confident are you that it's going to work when you get up there? Because you only had that grainy photo to work with to understand what was wrong.
We didn't know. We put as many tools as we could fit, with the notion that once the guys, if they did a stand-up EVA, once they got up there and saw what was really going on, maybe they could figure out the right things to do.
Yeah.
And so that's actually what happened.
Yeah, just get a human being up there and get the old Mark I eyeballs on it, and have them look and see what the actual situation is. And that's
so.
Go.
They didn't do the erection task until they had already entered Skylab and spent some time there, and then came back during that first EVA. Yeah. And did another EVA and pulled it out. The first time they went through, they weren't able to budget. They had a hook on the end of the pole, weren't able to budget.
They just tried to pull on it or something. Did I mark up the image here correctly? Like that solar panel, this is after it's actually been erected.
Yes.
Yeah.
Yes. So I put a big X over the solar panel. Yeah.
Yeah. It's not there.
Yeah.
If you want to point out the little parasol, the brown square in the middle of the the workshop, that was not there when they showed up.
Right.
That was added later to fix the heat shield. But I want a little bit of context as we're talking about the EVAs, as we're talking about the spacewalks. I argue that Skylab is underappreciated, and I feel in part because it's hard to remember that we ever didn't know the things that Skylab taught us, right? Today, with the Hubble Space Telescope, astronauts go, they fix the Hubble Space Telescope like it's nothing, building the International Space Stations. Astronauts are going out, doing all of these long EVAs, building a space station, fixing things that are broken. When we launched Skylab, they had practiced EVAs, they had kind of developed spacewalks during the Gemini program, and what we learned in Gemini was spacewalks are insanely hard. It's incredibly hard. It's incredibly unpleasant. You've got to make it as simple as possible. You really want to limit what astronauts are doing on spacewalks. You want to choreograph everything perfectly. By the time they do it up there, they've done it down in the tank countless times. They know every half move they're going to make. You've got it down. This idea that we're going to do a spacewalk and we don't know exactly what they're going to be doing, but maybe they'll figure it out. This is wholesale unprecedented in NASA history. If an astronaut goes on a spacewalk today, you see an astronaut in a NASA spacesuit doing a spacewalk on the International Space Station. On their right shoulder of their big puffy Michelin Man spacesuit, they've got a patch, and the patch has an astronaut in a spacesuit, kind of doing the Vitruvian Man thing. I should have dropped this in the pictures. I apologize. I'll see if I can find it. But it's got 5 stars around it, and the original version of this patch had 3 stars, and those 3 stars represented the 3 most important spacewalks in NASA history at the time. Ed White made the first American spacewalk, so he gets a star. It's the first. 2 guys, Neil and Buzz. I mean, they're not even in space; they're on a planetary surface. But even so, they get a star. The 3rd star is Joe Kerwin and Pete Conrad making the spacewalk to save Skylab. There you go.
Is this it? So, this is 5 stars, right?
Yes, that's the one. So nicely done. So at the time the original version of that patch was made, NASA considers that spacewalk that the first crew made to save Skylab on equal significance as the first American spacewalk, as the first footsteps on the moon. 50 years later, I would argue that Joe and Pete's spacewalk has had more historic, lasting significance even than those other 2. I mean, what that laid the foundation for with Hubble, with Space Shuttle, with Space Station. much more built on the foundation of what happened on Skylab, than even the other two of those.
Well, I mean, think about it. On the moon, you have ground to stand on, right? Like you can drop something and pick it back up again. There's gravity
Alan-
that helps you out. That's totally different than floating around free on the side of the Skylab trying to use a pruning shears to unclip a solar panel. Like
Alan Bean was the commander of the second Skylab crew. He was he walked on the moon on Apollo 12, so he had experience with both. He said doing a spacewalk on the moon on Apollo 12 was kind of like going outside. Doing a spacewalk on Skylab when that hatch opens, kind of like crawling out the wing of an airplane in flight. You just totally different experience doing a spacewalk on Skylab versus the lunar surface.
no kidding.
One difference is that we had the backup crew who had practiced all of these procedures in the water tank. That were Rusty Schweikart, Ed Gibson from the third manned mission was another one. And I think we've got a picture that Das, I think it is called.
Probably.
NBS Trainer in Water.
Trainer in water. I bet you that one has water in it. I'll get it.
It does have water. Yeah. Anyway, I mentioned earlier we had to convince the management council that this was not only safe but viable. So we quickly, there we go.
Is that it?
That's it.
Yeah.
That's a training session, a development session in the water tank. When we did it with this activity in mind, we had developed a sort of a mock-up of the solar array shroud and attached it to the side of the workshop in the water tank. All this has to be done in 2 or 3 days, but ultimately that EVA was practiced in the water, and Rusty as the Capcom during the real thing was able to be there and share his own personal experience doing that procedure in the water tank with the guys who were actually doing it in orbit.
No kidding.
And they made some modifications as they went along. A lot of this still came down to improvisation.
Real quick, I got to point this out because it's right here on the screen. You'll see the diver right there, right? Yeah. And that is in the water tank. There's bubbles going up. It's not NASA fakes, Skylab repair or whatever. No, they're training. They're following the procedure to see if it would work. But that is the scale of a human being on the side of Skylab here, right? Like this is the workshop. This is the telescope. The solar arrays would be going off like this, right? And when you look at these Skylab photos, just like the one that I showed, you're like, oh, okay, what a cute little spacecraft, right? But then flip back to here and look at the scale of the person and then realize the scale of the spacecraft. I'm not going to try to draw the diver on here or anything, right? But it's a lot bigger than you think. It's like there's no scale of a person on this. Anyways, Charles, go ahead.
And that made the workshop fun to be in, David.
Ah. Yes. So the workshop, I don't think we touched on this. So the workshop for Skylab, a modified Saturn upper stage. The S4B stage was both the second stage of the 2-stage Saturn 1B, the third stage of the 3-stage Saturn 5. Both used the S4B as their upper stage. So they took a rocket stage, and that was the foundation for the structure of the workshop. That's what they used as the as the basis for building the space station. But so that meant that you had the full volume of the third stage of a Saturn V. I mean, and again, the Saturn V is not a small rocket. You've got a third stage of a Saturn V rocket that you're using as your the basis for your house in space. I think 7.2 meters in diameter, Chuck? Is that right?
22 feet.
22 feet.
However that works out, yeah.
That's not small.
No.
So it remains, Skylab total was, I want to say, about a third of the pressurized volume of the International Space Station. If you add all of the U.S. modules, all of the Russian modules, all of the European modules, all of the Japanese modules together, it's about 3 Skylabs. But it had the largest open volume, to this very day maintains the largest open volume ever flown in space. There has never been anything like the. So what you're looking at here is the first floor, and the first floor was subdivided to give everybody their bedrooms, bathroom, kitchen, exercise area. The second floor was completely open, and so you could float around the second floor. There was a ring of lockers around the circumference, and they could run. I think I've got the GIF in there.
I got it here.
Yeah, this is what I want to see. I love this part.
Keep going.
They could run around the ring of lockers. Again, the thing's not spinning. There's no artificial gravity. It looks, watching the video, kind of like 2001, where they're in the spinning spaceship with artificial gravity. There's no gravity here. It's just you're running around. It's large enough that you can maintain the momentum to run around the ring lockers. They use this area to do gymnastics. What you're seeing him do right here, you could do. You weren't technically supposed to.
You weren't supposed
to. They figured out pretty quickly
after
the first mission that delicate things like the exact pointing of the telescopes that are making these very delicate measurements of the sun, that what he's doing right now can actually shake the entire space station enough that you're knocking the accuracy if you're pointing out some of the experiments that required really pure microgravity for the science experiments. It's shaking the vehicle too much.
It's like, let's launch a space telescope, and then we're running around on the inside of the space telescope. Why are my pictures blurry?
So the ground quickly. Okay, guys, you need to stop that.
Running. You got your footage. We can show it forever on now, but no more running around the inside.
But I think they did let each crew have their shot at. Okay, you can run around the lockers now, but
and then
today, no.
Oh gosh. And we're so used to, we're looking at the ISS, and we see people floating around in the ISS and sort of the size of those modules, right? Which had to be delivered for largely the cargo bay of the space shuttle, right? Some Russian ones as well. But they've got a size, and it feels a little small. And we haven't had anything like this in space. The ISS doesn't have this sort of room. Even when Bigelow did the expandable activities module, right? That just kind of got to the same size of the other modules, a little bit shorter, but you didn't get a lot more diameter. And I think the next time we're going to see something like this is when Starship gets up there. Because we've never seen anything, it's the inside of Starship or whatever. We always have these little ideas about how we're so cramped and we don't have a lot of room. And Skylab had this. You could run a lap around the inside of the thing. Look at all the room. There's actually a wall here, and it's sleep compartments. You're not just Velcroed to the side of the module or anything like in the ISS. It's a totally different thing. But anyways, what's next? More stories. We need more stories.
Well, I have a quick question, kind of going back to the EVAs, but even before, Chuck, you were mentioning the stand-up EVAs, which I think I saw in the documentary really meant that was the crew when they got launched, where someone was out the door and someone else was just holding their legs while they around the Skylab.
That's it. Yep.
That's bonkers.
It's bonkers. It is. It's sick, yeah.
I don't think I have a picture of that, do I?
No. Well, no.
Somebody holding on to somebody's legs.
Who would take a picture? Yeah.
Everybody was busy at that moment.
Everybody had their hands full of astronaut legs or solar panel loppers or whatever. They were busy.
Yeah, wasn't that how they got all the pictures of the up close of what the post launch?
Yes, and they tried to pull it away.
Yeah.
But all that happened is that the command module got moved closer, and that was not good. So they gave up on that.
Gotcha.
But at least at that point, we knew what was going on.
A real quick question, Charles. Well, no, you were saying something. Go.
No, go ahead. That's it.
There was a real quick question here, since we're talking about holding onto astronauts' legs and how big the interior volume was. Did any astronauts get stuck where they couldn't reach something, or they had to swim trying to use air to blow themselves to one side? Did they ever do any experiments like that, I wonder?
There was some, yeah. So because like you say, the International Space Station, most astronauts on ISS, you can't be anywhere that you can't reach out your arms, your legs, and push off against the surface.
Right.
It turns out Some of the very smallest astronauts, they can put them in the middle of the module and they're stuck. I can't vouch for whether I've heard stories, but Skylab, yeah, you totally could be out in the middle of the volume and you can't reach anything. Now, didn't happen often because usually, to get out in the middle, you've got enough momentum that you're going to keep going.
You're going to keep going, yeah.
But it did happen some. They did try. You were asking about swimming. They did try making like swim fins, like you would go scuba diving in out of cardboard to see how easily they could swim through the air of the space station.
Yeah, use the air
not very easily. But eventually, if you did get out there, you were just depending on the air currents. It had air coming in. You've got air vents bringing, circulating the atmosphere. So yeah, there were at least maybe once or twice that astronauts had to wait for the air currents to bring them back to shore.
No stories of like an astronaut sleeping and then they wake up and their buddies have put them in the middle of the big volume. They can't reach anything.
There's a little trivia issue about the airflow. However, in that large volume, if you ever lost a little bit of anything, a washer or a screw or whatever, can you imagine trying to find something like that?
Yeah.
In that whole big volume.
Yeah.
Most of the time, all you had to do was wait a little while, and it would show up on the air filter, on the return air filter. The air would eventually circulate, and your part would shall we go get pick up your part at
like sucked over.
Air filter number 3.
Yeah.
The other neat thing that occurred to me is you were talking about size. When the crew interfaces, the crew accommodations on Skylab were made and designed, they had to be designed to accommodate the 5th percentile Oriental female all the way up to the 95th percentile American male. That's a huge anthropometric range.
That's a big range of human body sizes, right?
Big range of human body types.
Yeah. So
there was a lot of analysis that had to be done using anthropometric charts and measure of man. Okay, what is your reach envelope for a particular size person? What are your visual envelopes and so forth? So any of the places where the crew had to stop and work, generically called a workstation, we had to do the analysis that assured that
you could reach.
That it was reach and visibility was a big thing.
Yeah, and it's not, say you're standing at your kitchen table, right? And how annoying is it to have to turn back around and go to this other cabinet, and you're preparing something at the sink, then you turn around, the stove's over here, right? And you're walking around your kitchen, and it's so easy because you've got gravity, right? And you can just take a step in this direction if you need to get the spoons out of the spoon drawer or whatever, right? But not the same on the space station, microgravity.
Maybe it's a good time to bring up another picture.
Is this one about barf? I have a barf logo.
No, not yet.
No,
not
I
yet.
can't talk about barf yet either?
I can't talk about it.
I've got S54 and I've got barf, but what's this one?
Try Owen Garriott.
Owen Garriott, okay. On Spacewalk.
On Spacewalk.
Got it. Here we go. Bam.
All right, so you see Owen at the sun end. That's the sun-facing shield. You see a little bit of the solar array sticking out in one direction.
Yeah.
Owen is his feet are clipped into a foot restraint. That foot restraint had to be at the exact angle that would optimize his reach envelope to be able to let him put the new film canister in the telescope on the end of the solar array and also reach around and retrieve the one that's coming toward him on this beautiful shiny thing called a bi-stem.
Is that this part here with the light reflecting on it? Okay.
That's right. So the beauty of the water tank is that we could put a foot restraint in the water tank. We could develop these angles and mounting positions on our own before the crew ever came. Not bother them with that. They don't have to fly to Huntsville to have that happen. So we would use our own test subjects, go through the procedure and optimize the placement of that foot restraint so that he can reach all angles and directions in order to get that job done.
I did.
The other interesting thing in this picture is that this tube that is sending the new cameras out to Owen was made by the same company that made the Canadarm for shuttle and the remote manipulator for space station.
Really?
It's called Spar Aerospace. It's now been absorbed into another company. But they had a really neat device. All the engineers perk up now. This is another really, really slick device. If you can imagine a carpenter's tape coiled up in a little housing, you go down to the big box store, Home Depot, Lowe's, whatever. There you go. Okay. All right. Das, pull that tape out and show us the little curve that makes that tape stiff.
There you go.
All
like
right,
the little
so,
curve, because it like, oops, sorry.
Yeah, and when you push it in, it flattens out and rolls up on a spool. Now imagine that you take that carpenter's tape and instead of having it 5/8 of an inch wide, I'm putting my hands up here.
Yeah.
You make it round so that it creates a cylinder. Now it's really stiff, but you can still flatten it out and roll it up into a housing. So Spar called this the storable tubular extendable member, STEM. And in this case, it was like a double-barreled shotgun. It had two lobes with an overlap. So this guy would go out and stretch out with a clamp on the end. The crew could take the cameras off. The guy his partner at the airlock end would flip the switch and suck this tube back in, roll it up, and get ready for the next one. It was really, really slick.
Okay, time out. Charles, I'm 43 years old. I have been using tape measures my entire life. And there's a reason I have one here at my desk, because I'm ordering things online and I have it clipped in a specific place so I can be like, how big exactly is 8 inches or whatever? And I pull it out and I can see how big things are. That's why this tape measure is on my desk. I have never in 43 years realized that inside the tape measure, it goes flat. And when you pull it out, it gets the curve so that it becomes stable. That has nothing to do with space at all. But I had zero clue that is how I have 20 tape measures around my house, and I had absolutely no clue that that's how that worked.
Spar had a history at that time of making deployable antennas for satellites that same way. They had big ones and little ones. This was one of the biggest ones that they ever had to make, and it was just extra special because it had the double-barreled shotgun.
No kidding.
Configuration to it.
Yeah, chat. Don't act. How many of you actually knew that inside the tape measure it was flat? Just like the thing we're showing on the screen right now, right? You're going to be able to pack it into a really small place because you have limited space on the spacecraft. You're carrying it up there, right? And then you want it to extend so you can actually carry the cameras, films, etc., right? And extend it a long distance, just like a tape measure. Who knew that was flat? I did not know that was flat.
Has to be.
No one ever knew. Look, nobody in chat knew that was the thing. 53 years and not a clue, says Amiga Clone.
You made my day, Dus.
I think this is going to be the big takeaway from today.
We should change the stream title and the thumbnail, like tape measures flat inside. What? But they used a similar trick right here so that they could have something that's stowed up very small, but then gave them reach abilities to reach the astronaut who... That's the other thing that I was thinking. It's like you're in the swimming pool. They have scuba gear on, right? Because this is how you train sort of neutral buoyancy working. And your feet are strapped to a specific spot. You don't get to like doggy paddle over or float over to another place. Your feet are attached to the spacecraft, right? In a specific place.
Darn good thing. It's a darn good thing because that's what made the difference between these EVAs and the ones in the Gemini program that did not have the foot restraints.
Yep.
Which caused the crew to overheat from the exertion of trying to maintain
the spot, as opposed to just being strapped into a place. And that's the thing. Go, you talk.
So the takeaway is that if your feet are located properly, you can do an awful lot. And if you look at Hubble, they not only had foot restraints, they had portable foot restraints with adjustable angles that they could set up. And this is just another extrapolation that makes the point. That what we did on Hubble and on was based on what happened on Skylab.
Because it's not like a TV show, y'all, where you're floating in space and you just happen to do this, and I'm going to do this thing. Right? Remember, if you even try to push on the panel or whatever, you get pushed the other way. And so, how do you not just go floating off into space, right? Staying restrained or positively like attached to the spacecraft, so that you have some sort of leverage. But even you don't want to be doing sit-ups for 40 minutes either to try and keep your upper body this way. So all of the thinking that they had to do on how they can work outside the spacecraft, Skylab is pioneering this. In not just the normal operations like replacing the film canisters and stuff, but the off-nominal operations, clipping the solar array or whatever, releasing the solar array.
And those were done without foot restraints.
Well,
that EVA was done without. Yeah.
Yeah.
That was what we all worried about. Could Joe Kerwin maintain his body position alongside the truss without a foot restraint and still help Pete Conrad do his job at the end of the long pole, cutting the strap with the cutter?
Yep, because what can you really do if you don't, we take gravity for granted so much, right? And I'm here, my position, and I can pick up a cup or I can move around or scoot a chair around, and gravity helps us do all that. But if you're there and you have one hand and two hands and you need to hand somebody something, but then you also have to hold on to a spacecraft, you've wasted half your ability if you're using one of your hands to hold on to something so you don't go floating off into space. And all of this, I'd never even thought about this with Skylab. I've never even realized that even me, like the space nerd, just takes it for granted. Oh yeah, they figured that out. And Skylab is figuring these things out so that we can build on it in the years later, right?
Yeah.
Nice. What time is it? We're so going to run out of time. We've talked for an hour. We haven't talked about BARF. We haven't talked about the S054 fix.
Wait.
What's next?
Summer's got a question.
Summer, go.
I want to hear another cool story, because beforehand, there is a connection between working on these, creating these footholds and everything, and doing some creative engineering that also then got done on Hubble by a certain astronaut. And there's a connection.
Who's been on the show.
Full circle. So Massimino and all of his having to creatively fix Hubble.
Massimino is he's the man when it comes to that kind of EVA.
But he was also your man.
Mike joined our group as a graduate co-op student, and he spent 2 summers with us early on in the Space Lab development process. We had we were responsible for training the crew, Space Lab crew, on scientific payloads for Space Lab.
Yeah.
So we had a facility at Marshall called the Payload Training Crew Complex. PCTC.
PCTC. It's got to have an acronym.
Got to have an acronym for
Initialism,
everything.
whatever. Yeah.
We had a full-scale mock-up of Space Lab, and we had emulations of all the payloads, science payloads in there. So we would do simulations there combined with the shuttle down at the Cape, and so we'd have half the crew in Houston and half the crew at Marshall. And Mike was really wanting to be an astronaut. He was a graduate student and signed up to be a graduate co-op. So he spent 2 summers with us, and he absorbed everything he could of NASA and in particular mission operations. And ultimately, you know what happened.
Yeah.
But it was kind of neat, because I remember my management asking, what's this guy Massimino doing for you? And I said, well, he's kind of doing his own thing. He's got some research he's doing.
He's doing his own thing.
You know, we gave him a desk next to Homer Hickam in Homer's office, and I'm sure Homer mentored him, and it was a good pairing. But I kind of had to defend because he wasn't doing anything directly for us. He was doing his own stuff.
He was doing his own stuff.
Yeah, and if I had the benefit of foresight, I would have said something like, well, we're planting a seed and we're letting it grow. And you've all seen the results of that.
Yeah. Real quick,
So-
for folks who don't know, Mike Massimino is with Intrepid Museum. He's been on the show lots of times. He does presentations at the museum, but he was also the astronaut who went up to, one of the many astronauts who were involved, repair the Hubble Space Telescope when it needed Hubble contacts or whatever, right? And new electronics and stuff. And Mike ran into the issue when he was on an EVA of a panel, a hatch, not a hatch, really, a panel that wouldn't open. And it was, well, how do we get this thing off? All the things that they tried to do didn't work, a lot like Skylab. This is off-nominal situation. Something's stuck, something's not performing to plan, and he actually had to rip the panel open, just like, well, I'll just brute force it. You know, after a lot of thinking and getting permission from Mission Control, I think.
Right.
So, no kidding.
So when Mike was there, we were also, another part of our group was working on all of those crew interfaces for Hubble. And just thinking back on it, if we had been smart and known what we know today, we would have put some handholds and handrails down the side of the S4B, anticipating that there would be a need to go do that. We didn't have that. We didn't have the benefit of that kind of prescience.
No kidding.
But
And now
it kind of all comes together, doesn't it?
Yep. Nowadays, you see astronauts riding the Canadarm too up on the ISS, right? And their feet strap in, and the Canadarm's like, "Where do you need to go?" Bzzz, and it just sends them wherever they need to go. And didn't have anything like that on Skylab. They had another astronaut holding onto their ankles, basically. Maybe not ankles, maybe a little, whatever. Hold on onto the legs. So, more stories. Chat says they don't care how long this show is. Just keep telling us stories, please.
Oh.
Nice, Charles.
David. Yeah, go ahead.
Chuck, you need to answer the man's question.
Right.
I don't care whether you do bar first or second, but we've teased the audience enough. You need to answer the man's questions.
I'm sorry, David. I missed it.
I said you
84-year-old ears.
Dawson's questions. We've teased the audience with barf enough.
What barf is?
We could get to barf.
Are we chronologically, like, in the history of Skylab to barf yet? Like, should we talk about that, or am I out of order?
You just did, and that's good.
Please tell me what this is.
This was all pretty serious stuff. Even though we spent some time sitting cross-legged on the floor playing with tools and Tinker Toy stuff, but there was it was kind of a high-pressure environment, as you can imagine. And at one point, our branch chief, Harry Waters, who is a good cartoonist, another one of those really, really inventive guys, decided we needed to have a way to kick back a little bit. So he and a couple other guys came up with the notion of an organization called the Bioastronautics Research Foundation. And if you look at the acronym, it's BARF. Well,
nice.
It kind of goes along with the fact that in order to join BARF, you had to have experienced all three of the simulation modes that we used for developing some of these crew systems: 1G simulations, neutral buoyancy simulations, and having spent some time doing parabolas in the KC-135, the vomit comet, as it is affectionately known.
This one.
And there is the picture of the KC-135 doing I think it's just prior to tipping over the top. If you get to that attitude and the pilot pushes forward on the yoke and begins to drop the nose down, you'll go through a parabolic trajectory that, with a good pilot and without a lot of atmospheric disturbances and turbulence and stuff, you can pretty well simulate 0G for about 20 seconds, 25 seconds, something like that. The downside of that is that when you get to where the airplane is going down now at the same angle, you got to pull up.
Right.
So now that's 2.5G pull up, something like that. And then that leads you into the next parabola. So you just do a series of these up and down. Every parabola, you get 20 seconds or so to do whatever you need to do.
Yeah.
So we used it as a simulation mode when we wanted to verify fine motor tasks, especially when it's suited in 0G.
Right.
And so anyway, BARF Barf met at some watering holes around Huntsville.
There were barf meetings?
There were barf meetings. A barf organization, a local barf organization, was called a bag.
A bag? A barf bag? Nice.
So we had the Alpha bag in Huntsville. We had the Bravo bag in Houston. What can I say? we had another one in Europe, and corresponding ones at Grumman and MacDac East and West. And then we decided we needed a queen. We needed a barf queen. And
a barf queen.
A barf queen. So we thought about it for a long time and decided you have to be as old as I am to know who this is. We chose Phyllis Diller as our barf queen. Do you guys know who Phyllis Diller was?
I don't, but she signed it Queen Barf Bag.
She does.
Summer, you're good?
Phyllis was a comedian.
Enlighten us.
Yeah. Go ahead. Summer,
older.
Tell us what you know about Phyllis.
I just know that she's hysterical and she's like an institution in comedy.
And she made fun of the fact she called herself ugly. She wasn't at all, but she made herself up to look weird, ugly. So obviously this is the right person to be our barf bag, our barf mistress, right? So we sent her a note and told her all about barf and asked her to be our queen, and she did send a real note back. We knew it wasn't done by a
PR agent
because she fixed it. Anyway, that was great fun, and it was kind of the oil in the gears we talked about before the show too.
Gotcha.
You need a little bit of that when it gets too serious.
And there's an official certificate and everything, I guess.
Yeah, there's more I could tell you, but I will not.
Not on this show. That's a different show. That's like After Dark or whatever, right? Oh gosh.
Trivia, the audience.
Oh no! What have we missed? There's a couple images I haven't shown. There's some solar time lapses. I think that was just showing what Skylab was looking at. We talked about spacewalk training. We've talked about the interior layouts quite a bit. I've got one labeled astronaut or Ed Gibson at an ATM, but I don't know why he would be needing to make a withdrawal on Skylab. I assume ATM stands for something else.
Yeah, he was controlling the telescopes that were making images of solar activity.
Okay.
Ed is a scientist in his own right, and he was operating all those 6 telescopes that were mounted on the Apollo telescope mount, looking toward the sun. And the control panel that Ed is at had all kinds of capability to control those 6 different telescopes, including the ability to point them.
Yep.
And time the exposures and so forth.
No kidding. Imagine all this on a touch screen these days, right? Like look at all these buttons and levers.
It would be. Yeah, these were all knobs and switches.
Yeah, physical. I bet you they click really nice when you switch them to aux or whatever.
They have to.
Yeah.
The crew makes us do it that way because they need to be able to feel that detent, that they know it's been actually flipped over. And some of them were guarded, had wickets on the side.
It looks like a fine control.
It's a fine control joystick, little bitty joystick there. And you see the ring around it?
Yeah. Oh.
He's got part of his fingers stabilizing his hand around that ring.
Yep.
So that if he gets bumped or moved, that does not get fed into the input to the hand controller.
We've talked about that on a couple other shows where if you're trying to do something with your hand and your hand is just free, like floating, and you need really fine control, it's a little tough to get really fine control. And so it's good if you have something else you can be touching at the same time, and then you use the fine control with your fingers. On the current Crew Dragon spacecraft, that was something that we learned they had to install down below even the touchscreens, a place where their hand could be while they're sort of tapping on these things on the touchscreens to make it easier to accurately tap on the screens. And that's all the way back to Skylab, where they're doing a little joystick thing here, and they've put a raised railing. I don't know.
If you ever watch an airline pilot through the open door of the cockpit when they're getting ready to go through their checklist, it's a beautiful, beautiful dance across the panel. They walk their hands I need to do that in front of you. They walk their hands from one spot to the next, so that they've always got a solid reference point with a finger or a thumb, because if there's a lot of turbulence, it's going to be hard to pick the right switch. So this is all an evolution from that. The amount of human factors analysis and simulation that went into that control panel was intense.
No kidding.
It was really. David, you getting ready to say something about that?
So, jump in anytime.
Quick trivia note on this this control panel. Next time you're watching Star Wars, pay attention on the inside of the Millennium Falcon, because the navigation console for the Millennium Falcon is a very close twin to the ATM control panel in Skylab. I mean, so Star Wars comes out 4 years after Skylab flies. They're making it, Skylab's still up there as they're making the movie.
Yep.
What does a spaceship look like?
What's a spaceship look like?
You got to design a spaceship. You want it to be realistic looking. This is the answer. So the Millennium Falcon, derives heavily from Skylab. A couple of years later, Alien, the look and feel of Nostromo and Alien borrows a lot from Skylab. Even today, For All Mankind, which is it's historic, but they lift a lot out of Skylab. There was a movie, Life, a space horror movie that came out, I think, 5 years ago or something. It's set in modern times, and yet even so, they're using Skylab as what a spaceship should look like. And so, even to this day, it's lodged in our public consciousness that what does a spaceship look like? Skylab.
Yep. Somebody in chat over here, Zap Fan, says that the thing in the middle looks like something Spock would look through on the Enterprise, right? Like, oh, let me do my science, and he's looking at something in this panel or something like that, right?
It's a little bit of...
was the other one. Battlestar Galactica, apparently, I have not gone back and seen this, but apparently they actually used the Skylab trainer from Marshall that's on display now at the U.S. Space and Rocket Center, and it's the interior of the Skylab, the Cylon base ship, apparently. Yep. So I've been meaning to go back and look that one up, because I just heard that recently. But yeah, that's our image of what a spaceship should be.
No kidding.
And before we leave, we need to add a little bit of real science in here. It wasn't all just fun and games, and it should be pointed out that at least one of those Skylab scientists, Riccardo Giacconi, who was really the instigator of X-ray astronomy, got the 2002 Nobel Prize for that was partially because of the work that he did on this mission in Skylab with guys like Ed Gibson taking pictures of the X-ray features on the sun.
No kidding.
That's pretty special.
Talk about a career-long dedication sort of deal, right?
You're taking a really big risk as a scientist with these long programs like this that take 8 to 10 years, sometimes more, of your whole career.
Yep.
And you're relying on somebody else's stuff to get it there and get it back and make it work. It's a big deal.
Yep, it really is. It's again, I mean, we explain things in a way that we can sort of understand these days, but so much of the stuff that we do today is built on lessons learned, right? Because there were people up there and they were strapping their feet into places and they were doing things that had never been done before. And how do we make sure we get the right switch? And how do we make in space, microgravity? We're not designed, we haven't evolved to work in that environment, right? And so when we are able to do it, it's because, well, maybe I could argue with myself a little bit. Our brains let us sort of figure that out, and we try something and it doesn't work, and then we come up with another idea and we try that, and we engineer these things, and maybe we are engineered to work in that environment because we use our brains to figure things out, physically. God, what other stories do we have here, y'all? What have we missed? I won't even mention SO54. I imagine you're just going to say SO54 when you want me to bring that image up.
Oh, it's not. Yeah, it's just one of those stories. You really want to hear about the SO-54?
I don't know. Chat, do you want to hear about the SO? Yes, they do.
Yeah, you want to hear about
They do. They do.
So, prior to the show, I had made a list of trivia questions to ask the audience, and one of the questions that I wrote was, at one point, the crew had to fix an experiment by destroying part of it. Anybody have any ideas?
The Skylab specifically had to fix an experiment by destroying part of it?
Yeah, there was an experiment. SO-54, here we go.
SO-54. All right, chat, go. You don't get to
Okay,
ask us today. You have to answer the trivia question. I just see a bunch of people saying yes.
I will answer the trivia question. SO-54 was one of the cameras imaging parts of the sun. And like a lot of astronomical cameras, there was a filter wheel. Summer, you probably know all about filter wheels.
Exactly, yeah.
It's a circle with windows.
Yep.
That as you rotate the circle, the disc, a different window will find itself in the optical train. Scientists are looking for images that are taken through a number of different filters that filter out parts of the spectrum. So SO-54 had a filter wheel, and you can see a picture of it down there that Das has brought up. Toward the end of the third mission, it got stuck. And it was not stuck in the open, clear part. It was stuck in one spot where they had already taken the images that they needed to get from that. So they still wanted to do some work with the scope. And the guys on the ground did a little work and found out that, in fact, if you took a screwdriver that was part of the toolkit that the crew had on board, you very carefully measured a certain distance back from the end and put a piece of tape on it, so you had marked that spot on the screwdriver.
Knew how long it was or how deep you were going to put it in. Yep.
You could poke that screwdriver through that filter medium that was in the optical train at that point, and use the screwdriver to lever the disc over to the next detent point.
Oh.
You had to be careful to do it because you could ruin the sensor behind it if you went too far, and if you didn't go far enough, you wouldn't have leverage. So that little drawing is what we put together to send to the backup crew so they could voice it up to the flight crew, and actually did. They did it, and they had to destroy part of that filter wheel in order to get it moved over to the open one.
Like they just stabbed it and they used that to get leverage to get it unstuck or to force it.
What it also did was validate the fact that you could do fine motor control things in an EVA suit under pressure.
Oh, this was an inside somewhere. This was an outside, an EVA.
It was even on that workstation on the side of the ATM. In-foot restraints, with the door open, with the camera removed, poking your head inside as far as you could get it.
Your helmet.
That opening.
Yeah.
The lighting was good enough that they could see down in there and do it, and it worked. But it's something that we simulated on the ground before sending that up. And they had to get permission to do it. Sure.
Yeah, of course. Of course they did. But here's the reason I was so interested in this, right? A lot of times when I get assets, when I get pictures or videos or whatever to show you all on the show, it's like, oh, this is from the Smithsonian, this is from NASA, this is from wherever, right? And these weren't labeled that way. It was just SO-54 fixed. And I've got another one here, SO-54 procedure. Let me see if I can bring that one up real quick. There you go. This is 5 of 10. Filter wheel moving procedure, right? But this isn't an image that has been downloaded from the Smithsonian or anything, right?
It's my printing.
Like your handwriting?
It's my printing.
It's your writing.
It's printing.
Printing. I'm like, what's printing? You mean like with a printer? Like,
yeah.
It's your writing.
With a pencil and paper.
Pencil. And so you wrote out this procedure with a pen and paper. Yep. And handed it, when you said you handed it to the backup crew, that's because the backup crew's on the ground and they're relaying it over the radio up to the astronauts.
Well, there's a teleprinter. They could use a teleprinter.
Okay.
Convert it to uplink There was a little bit of electronic wizardry available then. Yeah.
Yeah. So they took this procedure that you wrote.
Yeah.
and sent it up to Skylab so that they could be out on an EVA.
Well, I think they simplified it a good bit. This is what I sent down to the backup crew.
What you send down to the
But
backup
the neat
crew.
thing is, it's real. It's a real piece of history there.
Yeah, but they're on the EVA, and it's like, all right, you don't want to destroy the sensor, so make sure you tape off your screwdriver. Does everybody understand what we mean when we say that? I do this sometimes. You're drilling a hole, and you'll take the drill bit, and you'll put a piece of tape at the depth you want the hole, so when you get down to the tape, you know how to, it's sort of a thing.
You know what's wonderful about this story?
What?
It's what we're doing here is doing things in orbit that we would do in our own laboratory on the ground.
Yep.
That's the goal. I mean, isn't that what we're all about? Isn't that what we're really trying to do?
Yep.
Doing science in space means, as much as possible, doing things in orbit in 0G the same way, to the extent you can.
To the extent you can, yeah.
That you would do on the ground. So these guys were scientist astronauts for Space Lab.
Yep.
The next thing that followed Skylab, we even allowed the scientific community to send us their own candidates for astronauts who were scientists to begin with.
Mm-hmm.
And we've kind of backed away from that, but we're continuing that basic premise on ISS.
Yep. The same sort of thing. Like originally, astronauts were fighter pilots and test pilots, and all this sort of stuff. And we a lot of them weren't scientists originally, but then getting engineers involved. And then getting scientists involved. So the folks that are up there are doing their things. That's the whole, the intro video. It's orange, right? Do y'all know what that "it's orange" statement is from? It's from geologist on the moon. Saw a rock and exclaimed that it was orange. Not a fighter pilot on the moon or anything. A geologist who got to go to the moon and look at things and sees a piece of oxidized rock on the moon and says, "It's orange." And that, in our intro that you hear every time we start a stream, that is what that's coming from, because we had somebody that was not a fighter pilot, right? Who was a geologist trained to look at rocks in space, doing space things. But you make such a good point, Charles. I've said before, like, when there's graffiti in space, we're there, right? Like, it's a human thing for us to be up there. And we see in sci-fi, like, oh, their helmets are painted with their own logos and stuff, their own graffiti on their helmets or call signs or whatever. And it's more art. We've done shows with art in space as well. And when it's just all dry engineering or just all science, that's okay, cool, let's do that. But when humans get up there and humans are able to do human things, a lot like we do on the ground, that's really when we've sort of... That's what we want more of, right?
And there was, Chuck earlier, it wasn't just fun and games. There was a lot of science.
Yep.
Well, it wasn't just science. There was also a lot of fun and games. So there was a story I love to tell towards the end of the third crew. They get an extension. They're going to get to stay 4 days longer than they planned. So great, except they had supplies for 56 days. They're going to be staying for 60. And so they're kind of having to extend everything, to stretch out the extra 4 days. Well, they realized they've been, they were provided clothes, all packed ahead of time to last them through the mission. Okay, they have clothes for 4 days less than they're going to be out there. The jackets, the Skylab pants, like that's one thing. They realize we're going to be 4 days short of space underwear.
Space underwear.
So they send a message down to Houston, said, because there's another crew coming, right? This is the second crew, so the third crew is going to be coming. They're going to be up there for 84 days. They've got plenty of stuff. Maybe we could just borrow from the third crew. So they send a message down to Mission Control. Hey, we've been thinking about this. We sure would love some fresh underwear to come home with. There's some for the third crew. Maybe we could just have a change of underwear. And so Mission Control radios back up. The good news is you're approved for a change of underwear. The bad news is, Owen, you change with Al. Al, you change with Jack. Jack, you change with Owen. No. They now the one thing that they did get into and did get into the third crew's supplies was the butter cookies.
The butter cookies.
Butter cookies. So Skylab had I've said for 20 years, Skylab had the best food to ever fly in space. Just like the open volume has never been matched, the food has never been matched. Now, in the last year or two, I'm at the space station now. They're growing their own plants. They're eating tacos with fresh peppers that they grew. Hilton flew an experiment to bake fresh Hilton cookies on ISS. So, like, now it's a horse race. Like,
right.
It's hard to say who's got the better food. But up until the last year or two, without question, Skylab had the best space food. And so a lot of research going into it ahead of time to work with the crews. What would you like to eat? And we'll figure out how to make it in a way that you can eat in space. I mean, because there's real limitations. You don't have a microwave, right? You don't have a refrigerator. So there's real limitations. So it became kind of a challenge to, can we make X? So the crews got to come up with ideas, and the food group at Johnson Space Center would try and implement it for them. Pumpkin pie, they just couldn't do. The third crew was going to be up there for the holidays. They wanted pumpkin pie. You couldn't do it. So
Not
they got
happening.
Like bread instead. But apparently, the piece de resistance of the entire menu was these butter cookies that were so good they became the currency of Skylab. Like, that was, I'll do your chores for your butter cookies. And so by the time the third crew got up there, they had just a few left because the first two crews had eaten all of their butter cookies. My co-author Owen Garriott was really proud of this story. He figured out, so they were allowed to take, and I mean, and this is one of those things that really puts in context. This was 50 years ago, right? This was a space station. But this is a space station we were flying in the 1970s, okay?
Right.
This is not all the modern technology that we have now. These astronauts are in space. To listen to music, they're carrying cassette tapes. You can have 6 cassette tapes to last you for 3 months. Make your tape ahead of time, and that's all that you're going to get. I mean, now you carry your iPhone. Your iPhone is the size of a cassette tape. You can play music the entire time you're up there without hearing the same song twice. But back then, I mean, this is the technology that you get 6 cassette tapes.
Are we talking like 8-track? Like, what sort of cassette tape are we talking about? Like reel
to
reel?
I mean, we're talking, the same ones that I had growing up in the 80s. Your Memorex. But I mean, we're not that primitive. It's not 8 tracks. But let's get this straight. But so Owen decides he's going to take one of his tapes, one of his 6 tapes, he's going to dedicate to this idea that he has. So one day, Mission Control calls up to Houston, and instead of getting one of the other 3 astronauts that are living up there, they get Helen Garriott, Owen's wife. Hey Houston, this is Helen. How are you doing down there? Thought the boys could use a fresh cooked meal, so I came up to to Skylab, and it's coming down over the channels. And okay, so that's one thing, like that's fine. Except Helen goes on to describe the weather in California, what it looks like from space. Okay, yeah, right. How is she doing this? Because she's not patched through live.
Yeah.
So how does she know how to describe this? How does this work? And so the Capcom, the guy in Mission Control talking to the crew, eventually, okay, well, thanks a lot, have a good day, hangs up. And for I don't know how long, the flight controllers in Mission Control, I mean, like decades, did not know how Owen had done this. And so what he had done, because so Owen's one of the scientist astronauts. He's very logical. He's very meticulous. He plans this out ahead of time while he's on the ground, and so he starts thinking about what are conditions that might happen while we're in orbit. Maybe we're going to see a hurricane. Maybe there's going to be a volcano. Like maybe there's going to be. And so he has his wife record on one of his tapes multiple different versions of something that they might see from Skylab. And so when the conditions finally align, okay, something is happening that I've got on the tape. Like the Capcom was in on it. That was the one person that had a script that knew what Helen was going to be saying. So he sends a coded message down to Bob Crippen, who was the Capcom at the time. Like, okay, next pass, I'm going to have something for you. And so Cripps got his script, and so he's acting against his his script of the recording of Helen, and it's a great story, and it's a funny story, and he loved much later finally revealing this is how I did it. To me, way less funny than how funny the prank was just how proud this incredibly serious, incredibly smart, incredibly intellectual scientist astronaut, 30 years later is at unpacking how he had pulled this off.
He pulled off.
So, like you say, it's a great story, but it's lost. Just what an incredible human story.
Those are the things. I mean, we get lots of stories, right? And I feel like there should be more and more stories like that. Like everybody wants to hear, oh yeah, we did the science and all these reasons that we do it. But little stories like that, like people being people, right, in space, that sort of thing is just it humanizes it, right?
We want time real quick for the other Skylab rescue mission.
Wait, what? We are 2 minutes over the show. We're supposed to talk about another Skylab rescue mission too.
No, we'll save it for the 60th.
For the next show. Oh no, we didn't even talk about the whole not mutiny thing. Like this is one thing that a lot of people have heard about, right? Oh, mutiny on Skylab. It wasn't actually a thing. And we did this when we were going through the show. We're talking about some things we might talk about, and if you look at the Wikipedia page for the whole air quotes mutiny, it's like you can see all the edits, and it's like, wait, what? No, that wasn't a thing. And then all the corrections. Somebody tried to blow things out of proportion, but have we missed anything else we should be covering here? I mean, we're 3 minutes over. Are we? We are, right?
We are. Always leave them laughing.
Leave them laughing. This whole time, chat, I know that we have not taken a lot of your questions today. And we had so many interesting stories and things to talk about and explain and that sort of thing. I hope we were answering things maybe you didn't even know to ask about. Right? Because a lot of the times it's like, oh, how does this work? How does that work? Whatever. So many of the things today I was learning myself just talking through those things. So I know we didn't go through as many of y'all's questions as we normally do. I tried to get a couple in, but I really do hope that y'all learned some things. And that was part of the whole show today. I'm responsible for the thumbnail and the title. I am the one who put the whole spacecraft delays, crewed mission, et cetera, et cetera. But it was real. That was a real thing that was happening in the 60s, the 70s. And we've got Charles here, engineer who was on the ground solving those problems. It was his handwriting on the paper showing how that sort of stuff is. In too much today, people are like, oh, I only care if it's this, right? This is my favorite space company. If it's not my favorite space company, whatever, right? And there are so many stories and things that we can learn from that are important for people to be exposed to just hear about, to have access to stuff like this. So I didn't mean to I did mean to clickbait you in a little bit with the thumbnail, but I hope that you got something valuable out of our discussion here because it was about a spacecraft that was damaged in how they figured out whether they could fix that spacecraft before they went and sent crew up there. I mean, I asked Charles and everybody beforehand if we were okay running with that, and we were cool, right, Charles, David?
Yeah.
Yeah.
Yeah. Cool.
So anyways.
My favorite story.
Yeah. It's just cool. But that is going to bring us very close to the end of the show here. I didn't mean, I'm looking over here at chat and waving my arms at y'all when I look in this direction. But I do hope that you understand there are so many awesome things on these museum shows we do with Intrepid Museum every single month. And we always get folks like Charles, like Chuck and David here, telling us real stories that you probably haven't looked up. You don't know about because you didn't see them on Twitter or you didn't know to go look for them. But when you see the museum shows come up, maybe I won't be so flagrant about breaking news, spacecraft stuff. Actually, this was 50 years ago. But if you're interested in these sorts of stories, please make sure you make it back here, wherever you're watching, on the Intrepid channels, on the NASA Spaceflight channel, here on YouTube, you're over on Twitch watching or whatever. Just please make sure these are the sorts of things that we get when we have an Intrepid Museum show. Now, remember, real quick, I'm doing a little bit of the outro here. The museum shows are actually made possible through a cooperative agreement awarded to the New York Space Grant Consortium. That is a thing. They don't just happen. It does take a little bit of resources to get the shows going. So massive thanks to the New York Space Grant Consortium there. And then also thanks to our guests. Charles Lewis, David Hitt, Summer as well here as well, just hanging out. I actually labeled Summer nerd today. That was
apt.
cool, right? It's apt. I tried to fit space nerd, but it wouldn't fit. Thank y'all so much for taking time out of your Sunday to tell us stories that people should know about. Honestly.
Thank you for having us, and we so appreciate Intrepid and Astro Live featuring Skylab. Like you say, it is a story that more people should know, and it's great to get it in front of your audience. So we really appreciate the opportunity.
Yep.
I always have fun telling those stories. So thank you for my end.
Chat's screaming that we should go for another hour and a half. That may be another thing we need to schedule in the future as opposed to sitting here for 3 hours. But thank you so much for sharing your stories and your experience and that sort of stuff with us, Chuck. We really do appreciate it. Good deal. All right, y'all. Well, that does bring us here just about to the end. We do have a show coming up next month. Next month, going to be talking on Sunday, August 20th. And if I'm not mistaken, yeah, that one's about Psyche. We're going to be talking about a spacecraft that's going another place that we need to get some spacecraft to so we can learn more about it. But that's coming up Sunday, August 20th. For now, that is going to mark the end of our show today. Again, folks, I don't mean to trick you into watching stuff. I hope you like these stories. I hope you learned something. Be honest with yourself. And if the title of the stream was Skylab 50th Anniversary, would you have clicked it? And would you have missed out on those stories? Be honest with yourself. But for now, you would have clicked it. Charles would have clicked it. Good. We would have had Charles and me. We would have been the two people watching that. David, you probably would have clicked it too. Summer, you would have clicked it, right? We'd have 5 people watching. But anyways, thank you so much for watching. Summer, thank you for the time. Chuck, David, thank y'all for the time as well. Real quick, there were some books that you've written, David, that I didn't actually get a chat to link up. So if you like David's sort of storytelling there, would you say it was, Chuck, like a easy prose or something? Like just you can read it and it's interesting, right? Let's see here. I might have attributed that quote to somebody that wasn't actually making the quote. But there's some links you can click at in the chat to get David's books. One's Homesteading Space about Skylab. The other one was Bold They Rise. What was Bold They Rise?
So it's the space shuttle from development up through the Challenger disaster. They're both part of the Outward Odyssey series. If you're not familiar with Outward Odyssey, it's published by the University of Nebraska Press. The single best series on spaceflight history from early Chinese rocketry through modern commercial space. So I'm very blessed to have 2 entries in that series. But if there's anything that you want to read about in spaceflight history, there is an amazing book in the Outward Odyssey series that'll tell you about it.
Good deal. Yeah, the first links I posted in apparently didn't work quite right, so the last links I just posted there, they take you over to Amazon. You can find those books and more if you're interested in reading more stories like this. But I have now held us almost 10 minutes over our time. Thank you all so much for being a part of the show today. Chat, viewers, thank you for watching as well. Wherever you're watching from, make sure you follow the channel. If you see a thumbnail or if you see a title that says Intrepid Museum or something like that, click it if you like stories like this. But for now, that is going to be the end of today's Astro Live with Intrepid Museum and our fantastic guests here. And we will see you nerds later. We can all watch and I'll play the wave and I'll play the outro music now. Yes.
And here we go. We have liftoff.
Propulsion continues to be nominal.
RS-68 chamber pressure looks good.
Following up. Roger, planet.
Water towers, fly! Yes! Tango down to nominal.
Fighting downside FD off. Bring in FD off. It's orange!
Oh my god! Oh my god!
Décollage.
What is it?
Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane would be igniting in the flare, correct?
Yikes. You good? We don't need any more of these.